So these are the new formulas for your ellipse. All the other formulas are still good as far as the, like I think there's a formula about the c squared and a squared and b squared. That's still true for ellipse. But the ones that just had the differences, you'll notice like the x minus h, y minus k, that's the difference. The h and k here, the h and k here. These are the differences in the formulas from the previous ones. So it didn't used to have all these h's and k's. So that's the differences in the formulas. You go and write them down. Technically, these will work for when the center is at the origin as well. You would just have to plug in 0, 0 for h and k. Let's go ahead and use this. So the difference is the center is going to be different, right? So the vertex or the center, I guess the center for an ellipse, this is definitely ellipse because you got the plus sign there, is always going to be h comma k, right? So in this case, the h, hopefully you can see it, is going to be x minus h. So it's a positive 2, not a negative 2. And this is going to be a negative 1, not a positive 1, because it's y minus k. So 2, negative 1 is my center of the ellipse. And then you do everything like normal pretty much, except you're using that as the starting point instead of 0, 0. So underneath x is horizontal distance. So this is a bigger number. So it's going to, a is going to be 3. So I'm going to go 3 to the right, make a point, 3 to the left of my center and make a point. This is the smaller number. So with ellipse, that's b squared. So b equals 2. So I'm going to go 2 up from my center and 2 down from my center and make my beautiful ellipse. The major axis is this one, right? So a distance of c away from the center. So you might want to get us your formula sheet. Again, these formulas still apply. The c squared equals a squared minus b squared for an ellipse is still the same formula. So that would be, I guess, c squared equals 9 minus 4, or c squared equals 5. So c equals square root of 5, which is about 2 point something. So we go 2 point something in each direction. Make my point. That's a distance of c away from the center. And the actual ordered pairs, this is where it really might help to, actually, this is a horizontal ellipse. So you might want to use this formula, h plus or minus c comma k, to write down the formula h plus or minus c comma k. Let me just write that down. So the actual equation or point ordered pairs of those points would be 2 plus or minus square root of 5, because that's c, comma k, which is negative 1. So that's the best way to write it, with the exact values in there. Some people will use the decimals, and I'm not a fan of that. I like the exact values written in the ordered pairs. What's the equation of the conic? So we want to start with the center here. So your hk, or your center, is going to be this point right here, which is 2, negative 1. I like to write the h and k there just so it reminds me, like if you're using the formulas, it'll remind you, oh yeah, the h is 2, the k is negative 1. And so our formula is going to start, x minus 2 squared plus, because it's an ellipse, y plus 1 squared equals 1. And then the number underneath x, this is, it looks like the b value actually, because it's shorter. So this would be 9, b squared. And the longer value would be a. So a equals 4, it looks like. 1, 2, 3, 4. So this would be 16. Here are the equations for the horizontal and vertical hyperbola. The other equations would be the same, but the differences in these, obviously, is the h's and k's again. The h and k is the difference. It used to be like focus or plus or minus c comma 0. Now it's that slope is still the same. That didn't really change, actually. So let's use that to figure out the center. Now, be careful here. You notice with the vertical one, the h is the second value. So it's always connected to x. The k is always connected to y. So I want my h first. You always want to do h first. It'll just mess you up if you don't. So it's attached to x. So that gives me my h value, which if it's x minus 3, it'd be a positive 3 here. my k value comes from this. This would be a -1. So 3, -1 is the center of this particular hyperbola. Underneath, this is always my a squared for a hyperbola. That's just, so that's a is equal to 2. This is my b squared. Remember, a squared doesn't have to be bigger, so b is 4. So underneath x, I'm going 4 to the left and right. 1, 2, 3, 4. 1, 2, 3, 4. Underneath y, I'm going 2 up and 2 down. And then I like to make the dot box there, so you kind of put in the corners of the box. And then you want to draw in the asymptotes there. Identify the vertices. Let's see, this is going to be y is the first term, so that's vertical. So it's got to be the 2 vertical points. Those are the vertices. So that's a vertex. That's a vertex. And you're going to get out your, so let's just go ahead and graph it, right? So it looks something like this. Just goes through those points and approaches the asymptotes. And if you want to do the focus points, well, let's look back at the formulas. I really like to use the focus. So this is vertical, so it's focus points are h, comma k plus or minus c, h, comma k plus or minus c. So let's do that. That would be 3, comma -1 plus or minus, well, I need to know c. So for ellipse, I think this formula still holds true. It's a squared plus b squared for ellipse. So this would be 4 plus 16 is c squared. So c squared is 20. So c is 2 root 5 if you simplify. So plus or minus 2 root 5. 2 root 5 is approximately 4 point something. So I'm going to go up 1, 2, 3, 4 point something. There's my focus point. I've already listed the exact order pair there. I'm going to go down 1, 2, 3, 4 point something, and that'll be my other focus point. Code in this conic. Oh, it's so nice to give you the dot box there. So first you have to think, is it horizontal or vertical? It's definitely horizontal, so my x term is first. Definitely a minus. Just kind of putting the shell here for you. So that center, this point, it would be, I guess the hk would be -2, comma 2. That would be my h and k, right? So h is -2, so this would be +2. K is +2, so this would be -2. Horizontally, it's going 2 units, which means this is 4. Vertically, it's going 3 units, which means this underneath y is vertical. That'd be 9. And that's the equation. Translating parabolas. So this is actually an equation we've used earlier this year, so it's not as tough maybe as the, although I definitely write down these formulas. We're not, because we hadn't used the focus and directrix. So you can see the k values, you know, the h and k, those are new from the old formulas we had. So let's try this one. Let's start with an easier one. This is the y equals 1, so let's identify your h and k. So according to the formula, this is x minus h, so that'd be -3. And then -1 would be your k, because it's plus k. So -3, -1 is my center, or that's my vertex. It's my vertex, I should say. And so then, let's see, which direction is this opening? It's definitely opening, it's opening down, isn't it? So it's either up or down, it's negative. So my focus is going to be right below my vertex. So there's my vertex and my focus. So you need to go a distance of c. So c in a parabola is 1 over 4a. So 1 over 4 times -1/8, which would be 1 over -1/2, which is -2. So we go 2 down to get my focus point, 2 up to get my directrix. So y equals 1. If you'd rather use the formulas, right, the formula for focus is h comma k plus c. So let's try that. So h is -3, comma k is -1, plus c is -2. That should be the ordered pair, -3, comma -3, and it is, right? So you could have used the formula. So I just like to kind of draw it out, sketch it out, and kind of think it through. I just think it's easier. 2 units down is your c value. So I'm going to go 2c in each direction, so 4 in each direction. So 1, 2, 3, 4 from the vertex, make my focal diameter. 1, 2, 3, 4 from the vertex, and then draw my parabola. So you're using those focal diameter points. Again, this distance from here to here is 2c, or absolute value of 2c technically. Same thing here is 2c, or absolute value 2c. Since this is c is equal to 2, that's going to equal to 4 there. I know c is actually equal to -2. This is the absolute value, so it's going to be 4. And I think that's the graph. That's what you need. Let's try the tougher one. So h and k is the tough part here. Sometimes I get confused. So the h is actually this guy right here. So it's 1 according to the formula. And then y minus k, so k is a positive 2. So 1 comma 2 is my vertex. This one's definitely opening to the right because it's x equals and it's positive, so my focus point should be to the right. C is 1 over 4a, so 1 over 4 times 1/4, which is 1. So C is 1, so I'm going to go 1 unit to the, that's my vertex, 1 unit to the right will be my focus, 1 unit to the left will be my vertical asymptote, x equals 0. Again, you could have used all formulas to get that. I didn't use that. There's 1 unit there between the vertex and the focus. So I'm going to go 2 units up from the focus and 2 units down from the focus and make my points and draw my graph. Something like that would be your graph. And one more. So this is definitely an x equals. I don't know what a is yet, but I do know, so I'm going to leave it blank for a. It's going to be y minus k. Let's see, this is my k and this is my h. So y minus 0, I'm just going to write it in there. We'll simplify that in a second. Plus h, which is 4. Got to figure out my a value. So it looks like the distance between here and here. The c value is 4. Actually, it's -4 because it's opening to the left. So a equals 1 over 4 times c. So 1 over 4 times -4. So that's -1/16. So -1/16 would be my a value. That would be it. Or you could write it like x equals -1/16 y squared plus 4. You really don't need the plus 0. That's kind of overkill there. And if you wanted to put the focus would be 1, 2, 3, 4 units this way. So it should be right there. It should be equidistant with the directrix there. This one looks to be, let's see, a y equals. Definitely negative value there. So y equals, I don't know what a is yet, but so I'll leave a little blank there. X minus h. Let's see, h would be h and k would be h and k. So plus 4 squared plus 3. And the distance between the two looks to be c equals -1/2. It's definitely negative because it's opening down and it's 1/2 unit. So a equals 1 over 4c, so times -1/2 would be 1 over -2, -1/2, so -1/2 would be my a value. And I got it. It's not that much different. The principles are all the same, but you have examples. We could do this as a second lesson, so we'll go over some of those. What is a conic for our second half of the lesson here. So that's it for the first half. Let's see if we have a PSAT. No, we're good.